for the UK Midlands chapter at the moment. And we have tonight's presenting, we have a presenter, David Ross from IES, an introduction to digital twin for the built environment. Just a few house rules. So we have a presentation, and I believe it will last. It's not actually slides. There will be David will be presenting a live demonstration for us. So it's kind of quite a good learning exercise for all of us. And once David has finished, we will have some Q&A session. This will be chaired by Maru and Joshua. Maru is our currently serving vice president, and Joshua is the young engineers chair. And at the when you are listening, you are welcome to keep on your cameras, but please mute your microphones. And if any point, is it okay, David, to interrupt? If they have any questions, can they just raise their hands, or should they wait until the end?
I'm happy to take questions throughout. Maybe ones that are very sort of pressing. Yeah, I'll happy to take questions at the end as well. But
okay,
yeah,
maybe we'll leave it at the
if there's some really key, especially if I've got something on screen which you want to talk about, then feel free to raise your hand.
Okay. Yeah, if you have any urgent questions, then put your hand up and we will let you ask. And otherwise, wait until the end before the Q&A session. And obviously, you can send us emails if you want to find more information after the event. You can also send us an email at info@ashrae.co.uk or the ASHRAE UK. And David and IES allowed us to record this session, and it will be recorded, and later on it will be available on the YouTube channel. And you can go on to ASHRAE UK Midlands website, and you will be able to see today's session available there for you to watch or share with your colleagues. And on our websites, also we have the upcoming events for the coming months. And you can also find us on Twitter, LinkedIn, and also you can also join us on our mailing list if you would like to receive more information about our upcoming events. So thank you very much to all our sponsors, gold sponsors of WEXO and silver sponsor of IES, and we also have the bronze sponsors, EcoSense, Bizria Kingspan, Bispa Train, WES, HM Wilson Moran, and EN Sim. So further ado, just a quick introduction to our presenter. So David Ross is the Partner Operations Manager for the Intelligent Communities Lifecycle at IES. And he has been working, he's a chartered engineer and accredited low carbon energy assessor with over 14 years of experience. And especially at the moment with the climate crisis, and companies are looking to reduce their carbon emissions to achieve net zero carbon buildings, and I think digital twin is definitely gaining a lot more momentum. So thanks to David, he's going to show us how this could be achieved. So over to you, David. Thank you.
Thank you very much. I'm just about to share my screen, but in the meantime, I'll probably just turn my camera off just to sort of keep things flowing okay.
Sure.
There we go. You can see my screen okay, yeah?
Yes, we can, yeah.
Good. So hello everyone, and welcome to this sort of this webinar. My name is David Ross, and I'm going to present to you an introduction to digital twins for the built environment, specifically IES's digital twin technologies. So it's probably quite a good place to start is what is a digital twin? What's the definition? And well, the Centre for Digital Built Britain, they describe it as a realistic digital representation of assets, processes, or systems in the built or natural environment. So digital twin is what distinguishes it between maybe something that you may be familiar with, like a BIM model, or maybe if you're familiar with IES and their virtual environment software, what a digital twin is and how it differs from those is its connection to the sort of real asset. So take an individual building, for example. You can have your virtual building, but then you also bring in real data from that physical asset. And I guess a digital twin, there's no set rule on what a digital twin looks like or what it can be used for, and often what it actually looks like is determined by its what is to be used for. So if it doesn't necessarily have to be a 3D model of a building, it could just be some real data combined with some other data to do this. But with IES, we use our 3D modeling tools as well. So what is IES digital twin? We have on the left-hand side the data inputs, things like information about the building, could be things like building fabric, the building, how it's being used, the internal heat gains, the occupants, etc., along with likes of BMS or sensor data, and then anything to do with the systems or renewables. Now, in the middle of this, we have the analytics part of it. This is primarily the physics-based simulations combined with a bit of AI and machine learning. And then as an output of that, we can share this information using some of our other platforms, which are like dashboards, or if people are more interested in the sort of raw data, we have our sort of cloud-based analytics platform, which allows users to sort of really deep dive into the time series data. So applications of the digital twin technology, what can we use these for? So we can look at decarbonisation or net zero carbon roadmaps. We can use our tools to look at how a building or a campus or a city could decarbonise over a certain length of time. We can look at internal the well-being and health and comfort of the spaces. Things like predictive building asset management. So we can use the power of the simulations, the physics-based simulations, to predict how a building is going to operate and predict when maintenance may be required. And then we can look at things like moving away from individual building energy solutions to sharing energy. So it's probably good at this point if I show you some of the tools. So for those who are maybe not familiar with IES, this is our core technology, and this is what we use to model and look at the performance of individual buildings. This is the virtual environment, and you can see here we build up a picture of the model. So it's not exactly what architects use when they're designing buildings. They're using that sort of BIM, those sort of BIM tools, but it's a similar tool where we input all the sort of geometry and we can assign data against that. And we are more interested in the performance in terms of energy, carbon, internal environment. And if I just show you what we do, so we could build up the model. You can then through here also assign constructions. You can build your own building fabric and like construction. So if I double click on this, so I'm using two screens, you can then start to build up a picture of what's happening in that each and every element of the thermal envelope or internal constructions of the building. You have things like the systems, so the building services. It's always important to remember that buildings on their own don't consume energy. It's the systems inside it, really. So we can create systems, and we have a very simplistic way of doing this, or we can actually build up the systems in a different part of the program, look at every individual element and the controls of those, and really model those in detail. And then we, on a room by room basis, we can assign what's happening within that room. So this is a very, very detailed way of looking at building performance, and around 90% of new builds in the UK use this tool within the design process to look at the energy and carbon and internal environment. But it kind of stops when you get to the handover of the building. This once you've designed and the building's been constructed, there's no use for this model. However, with the digital twin, you can then take that and use it throughout the life cycle of the built environment. So to support commissioning and to reduce that performance gap. So by connecting the real data to your virtual model, you have a model there which behaves, and when you calibrate this sort of virtual model using the real data, so then the virtual model behaves and responds like the real building, and that means you can start tweaking the virtual model, applying different scenarios or improvement measures to and have full confidence in how the real building would actually operate and how it would react in real life without disruption. So with this model here, we build up a picture of what's happening, and we run some simulations. And these simulations, we're looking at all the thermal and energy transactions happening between rooms, between the external environment, depending on where it is in the world. So this model is in Singapore, this building's in Singapore, so we'll have climate data for Singapore. And then we can look at all those transactions down to 1 minute intervals, and it builds up a very, very detailed picture of what's happening within this building. And that's how we will look at a single building. But with IES, we are looking at tackling the built environment at bigger scales than just buildings. We want to start looking at multiple buildings. So we have another tool. One of our tools is it's kind of it's a plugin for SketchUp at the moment, and it allows us we can very rapidly, within a couple of minutes, import areas of urban environments, and we can then start to look at areas of cities, or we got a university campus, for example. We can model these scale of developments. So then, a bit like the sort of detailed building modeling, but on a sort of higher level, we can build up a picture of what's happening in the built environment. So things like the building fabric, the services, and this tool we use for things like early stage master plan or sustainable urban sort of analysis. We can build up a picture of what's happening in here and run some energy simulations like the other tool can, but then we can very rapidly build up sort of get some real good, meaningful data of what's happening at scale. And I guess this ties into this part here. So digital twins and the technologies, currently we're trying to decarbonize one building at a time. This is what the industry is currently doing, but it's a very slow, isolated and inefficient way of decarbonising, and we're very unlikely to achieve net zero carbon as a whole if we sort of continue on this path. With IES, what our tools allow people to do is they start to look at decarbonising at a far larger scale, and by doing this, we're far more likely to achieve our net zero carbon targets. So how do we do this? So this is just an example of a net zero sort of carbon pathway using digital twins. So what we do is we establish the baseline of the digital twin. So we create a digital twin either at scale or on an individual building level. So then the baseline behaves and responds like the physical asset. We can then look at the control and operation of buildings. So if you have an existing building, and it doesn't even have to be that old, you could have a building that was maybe handed over a year or two ago. That was designed based on industry standards, but as soon as you hand it over, the building changes, and it never actually performs as it was designed. So very quickly, the performance of the building drifts. And by just looking at using your digital twin to sort of look at tweaking the controls and operation of the building, you can very quickly get some low cost to implement, but large savings in terms of energy and operational costs. Once you've done that, we can then start using digital twin to test different scenarios. So we can look at shallow and deep retrofit measures, shallow being things like, could we replace boilers with heat pumps? Could we replace maybe the old fans or air handling units with newer, more efficient ones? And deeper retrofit being like of the building fabric. And after we've done that, and only once we've done that, we can then start looking at maybe local energy networks. We'll reduce the demand from the building, the actual energy demand, and then we're going to start adding technologies. So maybe moving away from individual building solutions and heating solutions and introducing a shared heat network. And again, then applying renewable energy technologies. So once we've run this model and we can get some good results out of it, we can then maybe start looking at, this is an example of what we could do with this data, is we can then start to maybe look at networks, looking at an energy network. So we'll have this tool here which allows us to look at different commodities such as heating, cooling, electricity, and we can build up we can build up our taking a university campus as an example. We could build up a picture of our campus, and as you can see here, we've got this is just an example we've got here. So we've got a hotel here, and we've got maybe 3 chillers in that hotel. We've got a primary school here. We've got 1 chiller. So we can build up a baseline to establish the energy consumption and carbon emissions from our baseline, and then we could also run different scenarios. So I could look at what happens if we move towards a cooling network and have 2 chillers and an energy centre here. So we could build up that scenario, and then we'd also plug in electricity to see how that impacts electricity and the carbon emissions associated with electricity. We could run in additional scenarios where we could look at adding in some additional buildings here. What's the impact on, if we have an existing cooling network here, for example, what's the impact on that network if we were to add in 2 additional buildings? Is there enough capacity in the cooling plant? What are the impact on the carbon emissions? And then we could start running additional scenarios, say, okay, if there's not enough cooling capacity to meet the loads of those 2 new buildings, what could we do? Could we add in an additional chiller, or could we add in maybe cooling storage? And within this tool, we can run lots of different scenarios to try and find the best solution for this site. And then, as you'd probably expect, we'll have the ability to incorporate renewables as well. So within the electricity network part of it, we have photovoltaics there as well. On the right hand side here, you can see the sort of list of assets we can add into our networks. So we've got heat pumps, electric vehicles, electricity heating and cooling storage, things like PV, wind turbines, and solar water heating. And if I just take the PV, for example, you're able to sort of you can customize each of these there. So for the cooling there, you can add in your cooling capacity for that chiller, and then you could build up your own efficiency curve there. So this tool allows you to consider what a network might look like for your site, and that could be a couple of buildings, it could be a campus, it could be an entire city, and that's things that internally at IES we do work and have some projects in the books, and we use our tools to look at things at such a scale. One example is Warrington. We have a model using this tool of the entire borough of Warrington, which has like 90,000 buildings in it, and we'll have all the data assigned against each of the buildings, and we're then also starting to look at networks. How can we share energy between different buildings with different parts of the area? And it's maybe worth as well just mentioning this as well. We can look at this in schematic view here as well. And against each of those virtual buildings there that you can see here, if I was to click on that, you can see there's a bunch of profiles sitting behind those. And those profiles, so let's take you can say the heating load or the cooling load. Those at this point for this model here, this is coming from this tool here. When we've run an energy simulation for this model here, the results from that simulation can be connected into this tool, and then each of those buildings has a profile. If you don't have simulated data or you don't have the sort of master plan tool, if you have this tool, the results from here can be used in here. Or if you have an existing development with real data, so from your BMS or sensors or maybe historic utility bills, you can bring those that data, those profiles into here as well. So we're not just talking about simulations. We can build up a picture of what's happening on, again, using a university campus as an example. You could build up a picture of what's happening on the campus, and you could start to test different scenarios to come up with the best solution. So the final tool, one of the sort of final tools that our digital twin tools will have is this thing called iScan. This is our cloud-based sort of data analytics platform. And what it allows you to do is collate any time series data. It could be coming from the real building, or it could be simulated data. It could be historic data that you have within a CSV file or different formats, and you can bring all your time series data into this platform. You can organize it, and then you can then start to, on screen, visualize it. If I look at here, this example here is I have data from 2015. I can look at data here for this. And this green here at the bottom here shows data quality. It's a huge part of it is with data is the quality of it. Just because you've got BMS in your building or you've got 1,000 sensors doesn't really mean or necessarily mean that you're going to have some good data there. It has to be logging the data at the right frequency, and quite often the data is collected and nothing's really done with it. So within this tool, you can start to have a bit more transparency of your data, and you can then start to run some analytics. So if I take this air handling unit 1 supply duct temperature, I can compare it with my other duct temperatures there, and then I could start to see if there's any trends or patterns or anything that sort of doesn't look right, and that sort of encourages me to sort of deep dive into something. We'll have different ways of visualizing that data as well. So let's take we have this overlay one. This is quite a good one. Is we can start to take every 24-hour period within the time frame I've selected is overlaid onto each other, and then you could again start to see trends there, and you can see if there's any outliers, and maybe that encourages you to deep dive into it and say where is it going wrong. And we also have things like heat maps. So it just takes a second to load the data in. And then we also have things like these insight tools here. So what the insight tools allow us to do is we have, if I take this one for example, I want to look at my data set, and I want to see between this time period here, are there any instances where the internal air temperature is above 28 degrees? And it tells me here, there's something happening here. So if the threshold for overheating was maybe 25 degrees, you can see here that there's many instances where it's overheating. So we have these a range of different insight tools there to sort of look at the data. And there's so many other parts of this. We can set up rules and alarms. We for the data. We can export the data. So if you have real profiles there from your building, you can export it and connect it to this tool here. So instead of using assumed profiles for, let's say for example, your lighting profile for a building or a room. Let's say traditionally you would maybe say something like, okay, the building starts to become occupied at 9 o'clock in the morning, and then by 6 p.m. the building's empty. However, in reality, you know from your data that there's a very sort of a different but fairly uniform profile across the year. You can take that data, that profile from our iScan platform, and then bring them into here and assign different profiles to your virtual building. So again, closing that gap, that performance gap between design and compliance-based methodologies with real data. So in the industry at the moment, we all know there's this performance gap, and with the digital twin, because you have this connection from the real building into your virtual building, we then start to close that performance gap considerably. Again, we can compare simulated data versus real data. So using our iScan platform, you could then highlight where there's maybe real where the building isn't performing as predicted. A good example of that, the power of that, is with likes of net zero carbon and decarbonisation, that the whole sort of agenda. Instead of waiting to the end of maybe the calendar year, to look at how your building or your built environment or your assets have performed, you could have real data coming in, and if you have maybe an alarm where the carbon emissions, so carbon emissions, you can't measure carbon emissions maybe with a meter, but you can use the electricity and gas or any fuel meters you have. You can bring that in, and within iScan, you can multiply that by maybe the carbon emission factor for that fuel. So you create a virtual channel, a virtual time series data. You can then track you can have your predicted sort of benchmark, if you like, of that building. And then if you have your real data coming in, you can compare those two profiles, and where the real data deviates from your predicted data, then it could flag up an alarm. So it then encourages the building manager or energy manager or sustainability manager to intervene far quicker than maybe taking stock of your asset or your assets at the end of the year. So I'm just going to touch on a few case studies of where maybe some of the technologies have been used. And we'll start with this one, the Nanyang Technological University, which is in Singapore. So they had a vision of becoming the greenest campus in the world, and then specifically by reducing their energy waste and water footprints by 35%. And then just here we're talking about the sort of process we've applied here, which I'll go into a bit more detail. So what we did, what was collaborated with NTU on this, the university, we built a campus level digital twin. So we modelled buildings at a high level, so we're not going into individual rooms. We created a site-wide model, and we assigned data against it. And then when we had that campus-wide digital twin, we then used it as a test bed for different technologies. So things like maybe improved lighting controls, or chiller efficiencies, or maybe looking at smart plugs, so we could look at turning off equipment out with occupied hours. And this is just as a result of that initial high-level sort of campus-wide approach, we were able to sort of demonstrate a 10% reduction in energy, and the 8.2 kilotons of carbon was saved, and I think that the 3.9 million Singapore dollars translates to about £2 million worth of savings. Then after that, we then went into a far more detailed appraisal than the campus-wide sort of approach. We started looking at buildings, and we have this process we call CI squared. This is something we use internally at IES. IES love an acronym. CI squared is collect and investigate, and then compare and invest. So the first stage of this is collect and investigate. You collect the data, and then you investigate it. So again, collecting from all the different available time series data, anything that was being measured on the campus, from utility bills, BMS, etc., and investigating it to try and look for hidden energy savings. So using our cloud-based analytics platform, iScan, we were able to sort of compare the different time series data, look at and if there's any sort of data gaps, we can use our tools to sort of fill those data gaps, providing we have enough data there to sort of to fill it. And then the next stage was to sort of to build individual building digital twins. So 21 buildings were created, and that was using our virtual environment tool. So again, we've done the high level one, and then we're now deep diving into the buildings room by room. And then yeah, the virtual BMS information that was assigned to each digital twin. So the data, the real data, is assigned to the virtual model, and then they become digital twins, or calibrated digital twins. And this is just like describing the process here. So this is the compare and invest part of the CI squared process. You have your digital twin, you assign your time series data, and then you have this hybrid model. You then calibrate it. So this is then once you've calibrated your model with the virtual building with the real data, that's when the model then starts to behave and respond like the real building. And once you've done that, this is where we simulated different options. So it could be 5 options, could be 100 options. You can simulate lots of different things, and that could be anything down from changing the set point of the cooling set point or the heating set point within one room, or it could be changing, stripping out all the natural gas and replacing it with electrical energy sources. Once you've done that, then you can identify the best option, and then look at maybe the return on investment, and that gives you a far more accurate and far more confidence in your decision-making process than traditional, because now you know that building, whatever you do to that building, will because that virtual building behaves and responds like the real building. Whatever you do, whatever you test, whatever scenarios you run in that building, you know will be reflected in real life, and then that gives you confidence when you're investing, and then we can monitor the savings and compare that against predicted savings. So by doing that, the savings were jumped up from 10% to 31%. The carbon emissions savings went up as well, and that 5 million Singapore dollars translates to about £2.5 million pounds worth of savings. And then this is a sort of final part of this sort of case study. IES were asked to look at the feasibility of moving from individual building cooling systems to a sort of district cooling system as well. So again, using that campus level digital twin, along with the sort of the 21 buildings, which were very detailed buildings, we then could build up a picture of how each of those of the cooling demand, the sort of the cooling demand for those buildings, and any sort of cooling system that any district cooling sort of system we predicted, and we had confidence that the figures behind those were very accurate. And this is just the predicted carbon emission savings for that. You could see that by moving towards a district cooling system, you can expect at times almost half the CO2 emissions. Secondly, in our case study is the University of Glasgow, and this is a fairly this one's in its infancy really. It's something which we're very much actively working on at the moment, and this is where we are looking at teaming up with the state's academics and IES acting as a technology partner to sort of have a living lab. And this is where IES provide all the tools and the training. The academics then can start using the digital twin technologies to within the campus or individual buildings. They could use it different parts of their course to they actually do all the modelling, and they have these interactions with the estates department, and they do go around the campus and survey buildings, and then the estates department can use those digital twins as an improved decision-making process. So the benefits of that is the academics have got up-to-date content, they're using cutting-edge technologies. Digital twins are very much a bit of a buzzword at the moment in the industry, and universities have to sort of keep up with the times. Students get real-world experiences through these interactions with the estates departments and surveying buildings, and that translates to employability skills. And then, as mentioned before, the estates department have improved decision-making tools there. That digital twin of the individual building or the campus, that's something that can sit with the estates department for the entire life cycle of the university and every building. And I guess we're not just talking about universities when we talk about that. Is any digital twin of an office or a school or a city, that is something that, providing it's maintained, it can last the entire life cycle of the built environment. Just going to show you one more. So our final case study. So again, it's another university, but what I'm showing you is another part of our suite of digital twin technologies, and this is our dashboards. So I touched on this earlier. We have these dashboards to basically turn raw data, this really all this sort of stuff here, which many people don't really know how to read or have no reason to sort of go into. It turns that into meaningful information. So these are sort of dashboards that IES have got that are fully sort of customizable, and they're interactive to help likes of consultants, engineers, design teams, etc. to take all the modeling stuff they do within their tools and pass it to their client, so the client can actually look at it and understand it. They could share it with key stakeholders. It could be used for the public, part of community engagement. It could be a display screen within a university or an office to show the performance of the building or campus or the entire portfolio. And I'll just show you a little bit here. So this is another university, Heriot Watt in Scotland, and what we've got here is we'll have this model, which is a portfolio model, if you like, and each individual pin here, let me turn this off. Each of these pins you could see represents a physical asset there. So if I click on this, you can see this is the Edinburgh campus, and we've got some other information there. We've got apologies, tells me the number of students within that campus. Again, these are fully customizable. And they've also got they've got a campus down up north. They've got one here in the Middle East and another one in Malaysia. And as this sort of grows, at the moment we've only sort of modelled one campus, but the intention is to sort of expand that out. If I go from portfolio level down to sort of campus level, we can then have that digital twin of the campus. So we take this model here that we've created within this tool, and it's pushed up to the cloud. And if someone has access to this web-based dashboard, they can now interact with that model. They can click on individual buildings, and we've got data there. So we've got an image of the building, we've got some sort of static data there, we've also got some time series data. If I click here, you can see the energy use intensity for on an hourly basis or monthly. And I could just enter this a wee bit, and you could then see what's happening there. So for this one there, natural gas, etc. So you can, and again, these are totally customizable depending on the project. This kind of ties back to with what we're talking about. What is a digital twin? And it all depends on what the purpose of it is, for what you want to, what do you need it for? And for this one, for the university, this is something which they can help. They can show their students, if you like. They can use it for the States Department. On the right hand side here, we've got some high level figures for the campus in terms of cost, etc. Electricity and gas consumption there. And then if we go down to building level, I take one of the buildings. We have another dashboard here for the building. It just takes a second at the moment because it's just pulling in real data here. And what you can see here is for this building, we have we've actually run some. Well, this is a calibrated digital twin of that building, and what we've done is we've tested a list of different scenarios. So these ECMs, these energy conservation measures, ranging from things like draft proofing, so reducing the air infiltration rate, applying insulation, moving away from gas to air source heat pumps, and adding PV. We've tested those, and we could use these dashboards as a sort of reporting tool instead of like a traditional 100-page document that goes and no one reads it. You can use these dashboards as sort of real-time reporting tools, providing we had the only thing that was inputted is investment cost for each of those measures, but we can predict the annual carbon savings and the payback. And these figures, and we've got some other sort of little tabs here that show for specific things like energy and carbon. Those can be maintained based on live data. So our iScan platform, this is connected to here. So you have real data coming into iScan and it connects into your dashboards. So these can just continually be updated and can automatically be updated based on the real data coming in. So I think that probably is that takes us to the end of the presentation. So I welcome any questions.
Okay, thank you very much, David. Any questions?
It's definitely a good thing.
So, David, you mentioned that the BMS data can be used using iScan. How dynamic is it? Can it report fault in the building as well as just predicting the energy consumption?
Yeah, it can be set up to report faults. As long as it's set up to do so, you can do that. We use our dashboards. We create these sort of command centers, if you like, and we've done it on various projects for a few different councils. Maybe a good example is there's a local authority in Scotland where we've got 30 odd schools there, and we have a different sort of portal for every school, and within that, the actual homepage has a list of every school there, and it shows if there's a fault on one of them, and then that encourages you to sort of dive into it and see what the fault is. And you could set it up again. It could be based on performance drift. It could be based on the values coming from the BMS. If a value's out with the sort of the intended range, then you could have a fault flag up, and an alarm could be raised. So yeah, absolutely.
Okay, Eddie.
Hi, David. Really good presentation, and thanks ever so much for that. I was just wondering about the raw data that's coming back from the field, and How because I mean I kind of do quite a lot of building performance evaluations going back to buildings, and one of the things we're always finding trouble with is actually the quality of raw data pickup. And I'm just wondering if there's, well, if you guys have had the same problems in getting raw data from real buildings, and kind of, I mean, I did notice that you've got some tools there that help with some of this. But how easy or difficult have you found it to actually get that raw data to help with the building of the digital twin?
Yeah, so bearing in mind that IES, we are primarily a software vendor, so we give people the tools, and a lot of people do what they like with them. So we don't always get the sort of feedback on other people's experience, but we do have in-house consultancy and R&D departments, and they do come across a lot of problems, and the problems range from things like the BMS system is not set up is maybe not as accessible. Perhaps it's not been logging the data that the end users maybe thought it was logging. Even when you start to bring in the BMS guys and round the table, sometimes it's not always easy. In certain instances, and not all instances, the BMS guys could be a little bit reluctant, perhaps, to offer the data, because if they have an FM contract, or the FM department has a contract with the client, they maybe don't want likes of other people looking at the data and maybe highlighting some inefficiencies. So there's definitely some sort of political issues there, and there's the technical issues, which is it set up to do it? And we have ways and means to connect that data to iScan automatically, so the system can be set up to automatically send data to iScan, or if it's an issue, then manually. But if it's set up to automatically send it, then it's how often do you actually need that data to come in, what frequency do you need it. So yeah, normally when you get involved in a project, or we get involved in a project, it's the data is the first thing that's looked at. What is the quality of the data? How accessible is it? And what needs to be done to resolve that? Because even though we could be appointed to look at a project, you might have to sit for 3, 6, 12 months before you could actually do something on it, because you need to set it up so you can start logging the right type of data.
Yeah, I mean, I can see where universities who, are single owner occupants of multiple buildings, they probably have a vested interest in making sure that they can get this data, because it will help them to reduce their energy costs. But when you've got kind of different buildings from different end users to on a particular maybe industrial campus or something like that, that's then all of this becomes a lot more tricky, and it's some of it, I suppose, will be to do with the specification in the first instance, because we invariably find that none of this kind of stuff is, I mean, everybody specifies TM39 and sub-meter and all that kind of thing, but there's precious the amount of data that's honestly being collected and absolutely nothing done with it, because it's not specified that something should be done with it, or how it should be collected and and then processed afterwards, post handover, is it's unbelievable, and really difficult to, I find anyway, really difficult to pull together to do anything meaningful, in the end of it. I mean, that's not to say it hasn't and it can't happen. It can be done, and some manufacturers out there are better than others. BMS manufacturers are better than others as well. So I do think we do need to be, if we are going to close performance gap, this is certainly one way in which we have to go. We have to move.
Yeah, I mean, we have a sort of partnership with a company, a large sort of multidisciplinary company, who part of their offering is sort of controls and through conversation, we're looking at sort of they're looking at sort of a digital twin ready control specification. So for new builds, and it's making sure that the control specification is aligned to the digital twin. But as I said before, digital twin could be for 1,000 different purposes, so it has to align to that. It's a specific project, and that means we have to be talking to the client and their team right from the sort of outset of the project, because by the time that it comes to sort of installing the controls and setting it up, it's kind of too late.
Well, maybe that's a worthwhile thing to do, actually, is to sort out some kind of a standard specification for data collection. You know, I'm not even sure whether there's even, you know, I mean, there's BIM standards, but I'm not sure whether there's actually any standards around, even with CIBSE standards or ASHRAE standards, for how data should be collected and then processed, you know, available for processing later. You know, so.
Thank you, Eddie. We got more, Zam.
Hi, David. Thank you for a nice presentation. I have a question with regards to creating a digital twin for a building. I mean, real-time recorded data is applied to the building, but how about the weather file or the weather data? Because the CIBSE provides weather files for 14 different locations in the UK, and for London, I think we have 3 different weather files. But the real weather conditions in a specific location, I mean, can we create our own weather data, weather file for, say, a specific location through a weather station, when we record data over, say, a few months, and then so that will reflect a real digital twin for a building?
So yes, so you can use the CIBSE data, but it is historic data. So you can create your own weather files if you have the data there available. There's no reason why you can't do that. I would probably say you want 12 months, because to reflect the sort of more of this sort of seasonal variations. But the on many projects, we'll have things like a local weather station, and it really is, they're very inexpensive for the grand scheme of things. If you have a less than, I don't know, £2,000 to £5,000 for a very small local weather station on top of a roof, then it'll pay for itself within the digital twin savings that you'd sort of you'd uncover over the first 12 months. So I guess it's if the local weather data isn't great, if it's not near your location, then it's maybe worth considering it.
All right. Okay. So I mean, a comparison can be done if we simulate a building with the CIBSE weather data and then the real data, so we can find out the difference. Plus, I mean, obviously, if there's a saving coming from the digital twin, saying millions, or the weather station, if it costs a couple of £1,000, so I think it's worth doing it.
Yeah. You can also, once you have that digital twin and once it is calibrated, you could also start to test future climate scenarios. So CIBSE do have the future weather files there, so you can then start to apply future 2050, 2080 weather files, the climate data, and then see how your building's going to behave in
future
those climates.
Yeah. All right. Okay. Yeah. Thank you, David.
You're welcome.
Okay, we got next link.
Yeah, hello. Yeah, it was nice presentation for today, and I'm so happy to join this presentation. And my question is about, as we know, I think this is quite new technology for the construction and for the AEC industry, but it's more concerned with the design stage. But I want to know how, because you said you have the project with Singapore and the different culture in the different countries. So I would like to know how you manage it and how real to communicate during the construction stage. because it's quite hard. I know it's quite hard to communicate with the construction stage people, because they have the different culture. So how you use this technology to communicate with them to manage this project?
So I guess from IES's perspective, again, just remembering we're more of a software vendor. We do have offices around the globe, and those we do have a Singapore office, and they are very, they know how to communicate and approach these different clients. But there are different parts of the world that are maybe less open to this, or they don't see this as necessary as others. I guess in the UK, I think the built environment, at least in the AEC sector, it's that they're a little bit more. I think this is a natural progression from BIM. BIM, digital twin it's kind of BIM with an extra dimension. You're bringing in the time dimension there, and so it is depending on the sort of maturity of the markets you're sort of looking to operate in. Then I guess you have to consider it is, are they open to change? And I mean, digital twins in the built environment are a fairly new sort of concept, but in many other industries, the digital twins have been about for a long time. So, likes of aerospace, automotive, and industrial sort of processes, that they have digital twins. Tesla, for example, they have digital twins of every car. So, and that's real data comes back, and then they use that to enhance maybe future, or to sort of support this sort of future development. But also they can maybe use those to push quick fixes into cars. And I guess this is where digital twins could go, and we're already exploring the idea of using these digital twins to sort of eventually you could push instructions into the building. You could simulate the impact of maybe tweaking the heating set point by 0.5 degree, and then you could implement that from a remote place. So again, a bit like they could do that already, but it's integrating that into a platform like we do. I guess FM teams are very much, and again, not all of them, but many FM companies are very or mainly concerned about the operation and efficiency, but many are not really interested or too have too much of a interest in the sort of the carbon emissions and the carbon savings and sustainability KPIs.
Okay.
They're maybe not as interested in things like health and well-being of occupants of buildings, but with the digital twins you could start to then use that. And again, depending on where in the world you are, different cultures have different priorities. So the digital twin's flexible. The IES's digital twin platform is so flexible. You can undoubtedly use it to sort of suit the what your culture or the sort of market you're operating in demands.
Okay, thank you so much.
Okay. Joshua.
Yeah, there's a question in the chat by Rodrigo. For the simulation scenarios, can a Monte Carlo analysis be done, or these scenarios have to be manually produced one by one?
A Monte Carlo analysis, as in the geographical location, the actual place. If I'm reading that as though can you run a simulation for a building or a campus or an area within Monte Carlo, then there's no reason why not.
Rodrigo, do you want to go with the question?
I guess touching back onto the sort of weather, the climate data. If you have climate data for Monte Carlo, then you can run some simulations against that, and yeah, the results will be reflective of the location.
Okay. Any other questions? I think Joshua, Rodrigo.
Yeah. So, yeah, okay. I think he asked about different scenarios, like, proper insulation, glazing, and everything can be done, at a single time or have to be manually produced one by one.
Excellent. Well, if there's no more questions, then I think we should probably round things up.
Yeah.
Yeah.
Okay. Thank you very much. Guys, if you want to put your camera on, we can take a photo, but if not, that's okay. Don't worry about it. And Joshua, when is the next event?
Just get my calendar. It's a SIBC ASHRAE joint event. So it will be on the 24th of November. Yeah.
Okay. Joshua, if you want to take a photo, we're going to take a photo for the web page. Thanks very much.
Yeah, 1 second. Cheese. Okay.
Okay.
Yeah.
Thank you, David. Thanks very much. Thank you. And thank you all for attending. See you soon. Take care.
Thank you very much.
Bye.
Bye.